I talked about the concepts in both shorts and a complete video for unsupervised learning. And all of these are going to be done on Iris dataset, and you can get Iris from Sklearn from this line. And okay, let's very quickly go through the libraries that using the data frame from pandas. And then you have PLT, and you have matplotlib, which helps us to visualize the data. For example, you can make different types of plots, scatter plots, histogram, and things like that. You can get all of them from Matplotlib. And also another one that you can use for the same purposes is Seaborn. And then when you're using as, that just means that whenever you want to write your code, instead of writing pandas, you just have a shorter version of it like PD. And for Matplotlib PyPlot, you're just using PLT. From sklearn, we are loading Iris dataset, and then these are going to be all of our clusters. We have k-means and dbscan, and then our metrics are going to be silhouette scores, just going to say how well our clustering has done. And then I have PCA. It is going to reduce the dimensionality, because the more dimensions that you have, the more complicated your data set is going to be. And you have standard scalar here. When we were talking about machine learning and AI, yeah, you need to understand that they are using math. So they don't really understand the units. So it doesn't understand that 1 kilogram is the same as 1,000 grams. So it will give a much higher weight to 1,000 gram than to 1 kilo, while these two are the same. You want to make sure that you're using a standard scalar to scale them. So these are all types of clustering. Iris dataset have 150 rows. That means that it has 150 data that you can use. And then each one of them have 4 features to distinguish these different types of iris flowers from each other. And there are 3 types of iris flowers. Another thing to keep in mind about this data set is that it has both target and data. It can be used for supervised learning because it has labels. So it means that each one of these flowers that it describes, at the end, it will tell you what type of flower it is as well. Since we are using unsupervised learning, we don't really care about the label. We mainly care about the data. But if you're using it in supervised learning, both of them are very important. So you remember we talked about standard scalar here. Now we're gonna scale our data. Then in the standard scalar, you're using fit transform. Fit transform just means fit is going to calculate, and transform is going to actually change the data to a standard form. The first clustering that we're going to examine is k-mean. We said there are 3 clusters, so we're just going to pass 3 clusters. You can make it more or less if you want. There is something here that is called random state. You want to make sure that every time that you run your code, you're going to get the same result. In order for you to get the same result every time, you have to set random state, and you can set it to any number. For now, you can set it to any number. It's just that you want to get the same result every time. So then here we are using k-means fit and predict function. So what it does, fit and predict, fit again means that it will learn the pattern predict in the cluster of each one of the data points. Here we calculate the silhouette score to know how well our k-mean did, and then we're just going to print so we can see the results. And after that, we're going to talk about dbscan clustering. We can use epsilon to say how far away the points are going to how, when you're creating that circle that we talked about, or that sphere that we talked about, what is going to be the distance of that sphere, which is around the data set. And then we have mean samples. So that means that when you decided on the radius of that sphere, you're going to figure out how many data points have to be in that sphere. Again, we do fit and predict. So then we're going to the silhouette score again. So when we're talking about silhouette score for dbscan, because dbscan can recognize the points that are far away, and it will consider them as noise, so it won't assign them a cluster. For those points that dbscan doesn't consider in the cluster, it will give a value of -1. Next clustering is going to be hierarchical clustering. So first we're talking about the linkage. Linkage is just the way that you wanted to calculate the distance. Okay, here in this one we're using the method of Ward. There are multiple types of linkage method, and you can experiment with them. In hierarchical clustering, as I said, we're not gonna tell it
how many cluster it has to form. But we have a way to indicate how many clusters we have. First of all, this z is just the linkage, and then that we talked about before. And then for t is equal to 3, we are saying, okay, so we have this tree for our hierarchical clustering. Cut it in a place that we are ending up with 3 clusters. And then you have criterion that has maximum clusters, means that you don't want it to exceed t, um, uh, the number of clusters, which is 3.